Hello guys, welcome to this channel. We do some experiment, and for disclaimer, this video is for entertainment and for views purpose only. So, in this video, we are using potato guys. I know you have in your kitchen potatoes. Then, if you have 1 potato, 2 potato, 3 potatoes, you can use it guys, as long as it's potato. So, without further ado, let's start the experiment.
Here at Science Buddies, we get a lot of questions about our Veggie Power project. This is a classic and perfectly legitimate science experiment where you build a battery using potatoes or other fruits or vegetables like lemons or onions and use it to power something like a tiny LED or one of those little solar-powered calculators. However, you have to be careful because there are a lot of videos online claiming you can use these batteries to power something much larger, like a full-size light bulb or charging your cell phone. What we're going to do in this video is go over the science of how these batteries actually work and how some of the hoaxes behind them are perpetrated, so you can decide for yourself when you see one of these videos if it's real and if it's something you can reasonably expect to try for a science fair project. First, let's talk about voltage and current and what we can reasonably expect from one of these batteries. Here's where it helps to read the small print. If we look at a common LED light bulb, we'll see that it's rated for 120 volts and 142 milliamps. We're not worried about the difference between alternating current and direct current for now. If we look at a cell phone charger, again, there's a lot of small print here, but the part that we care about is the output to the phone, which for this charger is rated at 5.1 volts and 2 amps. Let's compare that to what we measure from the potato battery using our multimeter. If you don't know what a multimeter is or how to use one, check out the link to our multimeter tutorial in the video description. If we set the multimeter to measure the battery's open circuit voltage, we get less than a volt, about 0.9. If we set it to measure the short circuit current, we get less than a milliamp, about 0.4 milliamps or 400 microamps. That's a lot less than what would be needed to power either the cell phone charger or the light bulb. Now, voltages do add if you combine batteries in series, and currents add if you combine batteries in parallel. So in theory, you could combine enough of them to get enough voltage and current for either the cell phone charger or the light bulb, but you're going to need a lot of them. So if you see a video claiming to charge a cell phone or power a light bulb with just a single potato, it's probably a hoax. Now let's talk about battery chemistry. You don't need to fully understand the chemical reaction to get the basic idea, so don't worry if this diagram scares you. If you do want to read about the chemical reactions in more detail, click the link below the video. The basic concept is that there's a chemical reaction between the metal electrodes, usually copper and zinc, and the electrolyte, or the liquid inside the potato. In order for a potential difference to be generated and for current to flow, the electrodes need to be two different metals. If the electrodes are the same metal, then there's no potential difference generated and no current will flow. Again, we can demonstrate this with our multimeter. On the left here, I have a potato battery with 1 copper electrode and 1 zinc electrode, and as I demonstrated before, I can measure the short circuit current of this battery. On the right, I have a battery with 2 copper electrodes, and if I switch the multimeter probes over to that one, we can see that I measure 0 current. This gives you something else to check for when watching a video. The pins on the inside of a USB cable are all coated in the same type of metal, usually a copper alloy, although more expensive cables might be gold-plated. If I plug that cable directly into the potato, I only have one type of metal contacting the electrolyte, so there's no voltage difference and no current can flow. The same concept applies to the base of a light bulb, which has 2 different contacts, but they're both the same type of metal. So again, I can't just plug the light bulb directly into the potato and expect it to generate a voltage. Next, always be wary of things you can't see clearly or that aren't explained well in the video. For example, I've framed this shot to imply that the same USB cable that's plugged into the potato is also charging the phone, and I have my phone screen on to prove that it's charging. However, what you can't see out of the frame is that this cable isn't plugged into anything, and this is a completely different cable that's plugged into the phone's regular charger. So if you can't see something clearly, don't trust it. What about the light bulb? This one might seem a little more convincing at first. Here I have a potato with a hole cut in the top and what appears to be a regular light bulb. When I insert the bulb into the potato and screw it in tight, it lights up. And this time, it looks like I don't have any hidden wires or cables. The secret here is that this is actually a prank light bulb. I have a second one here that I've disassembled, and when I remove the base, you can see that it has a AA battery and a smaller light bulb hidden inside. When something conductive, like a piece of metal or the electrolyte inside a potato, closes the circuit by touching the two contacts on the outside of the socket, it causes the bulb to light up, making it appear as if the bulb is operating with no true power source. You can just buy these online, or even build one yourself by carefully disassembling an old light bulb. So this gives you something else to watch out for when you're seeing a video. There could be a hidden battery inside. Well, this AA battery is pretty large, and we would be able to see it if we had a clear light bulb instead of a frosted one. There could be something even smaller, like an LED and a coin cell battery, which would be small enough to conceal inside the base of the bulb itself. Finally, be on the lookout for any claims about free energy. There is no such thing. There are a lot of pseudoscientific claims online about magnets and free energy or perpetual motion machines, so a video might tell you to do something like wrap a magnet in a coil of wire and plug the wires into your potato. While it is possible to generate electrical current using magnets and wire, it requires relative motion between the two. They have to be sliding back and forth or rotating with respect to each other, and we have several projects on the Science Buddies website that demonstrate that. However, just wrapping a magnet in wire and plugging it into your potato like this won't do anything.
Whoa, it's 100% working. So, if you have potato in your kitchen, you can use it. You can try this experiment, guys. It's 100% work. You can use it in your phone. Your phone charge. If you try this. It's really cool, guys. Yes, it's really cool. Use potato, guys. 1 potato, 2 potato, or 3 potatoes. As long as it's potato, you can use it, guys. If you think it's helpful, please click the subscribe and hit the notification bell for you to be updated on my next video, guys. I have many videos to be uploaded in the future. So, hope you like it, guys.